for all these problems, I encourage you to try them first and then come to the video. But we should know when we see these directions, right, that the first thing we have to do is take the derivative. It is fair game for me to ask you to factor something where the leading coefficient is something other than 1, right? Here's where we've got to use our factoring skills that kind of take it up a notch, right? Because A is not 1. Fortunately, if we do the AC method, right, we get positive 3. Okay, this is not going to be very hard to figure out what factors to use. What are the factors that multiply to positive 3 but add to negative 1? Okay, so that is, of course, this. Okay, so when we go to factor this, I'm going to come over here and do it. Right, we rewrite our middle term. Negative 4 can be rewritten like this. Okay, so I group. Okay, I take out a 3x. I'm left with x minus 1. And then over here, I pull out a negative 1. And I'm also left with x minus 1. Okay, so this will factor. And once we factor, we set our derivative equal to 0. So here's our derivative in factored form. 3x minus 1 times x minus 1. Okay, so we set each factor equal to 0. I'm going to assume this one you can easily do in your head. I don't know, maybe you need to do the arithmetic on this one, right, where we set this equal to 0. Okay, we add 1 to both sides, and then we divide both sides by 3 to get x equals 1/3. Okay, so those are the numbers when we take our derivative, set it equal to 0. Those are the numbers that go on our number line. All right, so I'm going to put 1/3 and 1. Well, that's 1/3. So then we know that we have to find something in between 1/3 and 1. Okay, so again, asking you to have a little bit in the way of fraction skills is totally fair game. Over here, I'm just going to write T for test. I'm going to test 2 because that's bigger than 1. That looks like a positive 2. That's all right. You know what I mean. And then I'm going to test like negative. No, actually, I'm going to test 0. 0. I love testing 0. Okay, so test 0. What's in between 1/3 and 1 that would not be so bad to work with, right? 1/3 is 0.33333, right? So something common between 0.333 and 1. How about I test 1/2? Okay, so I expect you to have some just basic fraction skills here. So I go to test, and you always want to look to the factored form. I always want to look right here. Okay, so if I plugged in 0 here, I'd get 0 minus 1. So let's see, that is a negative. And of course, 0 minus 1 again is a negative. So I get that the first derivative is positive, telling me that my function is increasing. Okay, if I test 1/2, so 3 times 1/2, that's 3 halves. 3 halves, that's bigger than 1. Okay, so if I take away 1, I get a positive, but if I do 1/2 take away 1, right, 1/2 is smaller than 1, so I'd get a negative. Okay, so here the first derivative is negative. And then let's test 2. That's pretty easy. 6 minus 1, 2 minus 1, right? Those are both positives. So I'm going to get a positive. Okay, so then I can answer the first part of this question, which is where's my function increasing, decreasing? Where's my max? Where's my min? So over here, I'm going to write, and we can see this by the way the arrows go, right? Think of the arrows as going like, showing a function going like that, right? That's what my function's looking like. So I have at 1/3, I have a max. At 1, I have a min. Okay, I'm going to leave a spot here for point of inflection because we're going to find that in a minute. And then let's see, so my function is increasing. So where's it increasing? Where's it decreasing? Okay, so I'm increasing everywhere the derivative is positive is where my function's increasing. So I'm increasing from negative infinity to 1/3 union 1 to infinity because that's where it's positive, and then decreasing from 1/3 to 1. And now I'm only halfway done. Gosh, I thought I left myself enough room here. I'm going to run into the second question. So I'll just mark it off like this and keep doing my work over on the right. Okay, so this just answered the first part of the question. So for the next part of the question, I have to take the second derivative, okay, to find point of inflection and intervals of concave up and concave down. So come back to this form of the derivative, right, to take the second derivative. Come to here. So that's just your basic old power rule. Take the second derivative, which would be 6x minus 4. Okay, we set that equal to 0. Okay, so 6x minus 4 equals 0. Add 4 to both sides, right? And then divide both sides by 6. I get 4/6, which I hope we can easily reduce down to 2/3. Okay, so we get a value in between 0 and 1, which makes it easy to decide that when I go to do my number line, right, all I have to put on there is 2/3. Okay, so 2/3 goes on my number line. And let's see, I'm going to test 1 because that's bigger than 2/3. I'm going to test 0, right, because that's less than 2/3. So let's see if I put 0 in. So I'm looking right up in here, right? If I put 0 in, I'd get 0 minus 4. So the second derivative is negative, concave down like a frown. If I put in 1, 6 minus 4 is positive. So I do know I have an inflection point because the signs have changed. Okay. So I can go back up here where it says, what's my point of inflection? There's my max, there's my min. Point of inflection, x equals 2/3. And then where's it concave up and concave down? Okay, so concave up from 2/3 to infinity. Concave down from negative infinity to 2/3. And that completes that problem, right? Which we've done plenty, right? That's a pretty involved problem. All right, I want to show you one other thing. Let's suppose I gave you the derivative, all right? Because once in a while, I won't make you find the derivative. I'll just give it to you. So we can see here that the critical values are 3, positive 3, and negative 4. Okay, so negative 4 goes on here, positive 3 goes on here. What I want to show you, all right, so let's say I'm going to test 4. Test 4. I love testing 0, so the T stands for test. Test 0 and test negative 5. Okay, and I want you, when you're doing this to show your work, to put this in parentheses so that I know which ones are your critical values, which ones are your test values. So let's see, test negative 5. Well, notice this is positive no matter what I plug in. Okay, it's always positive because it's squared. So I put negative 5 in here, and the first derivative is negative. Okay, I put 0. Well, this is always positive. Put 0 here. First derivative's positive. Okay, so it looks like I've got myself a min at negative 4, right? Negative 4 is going to be a min, and make sure you write x equals when you're expressing your answer. We don't just say min negative 4, x equals negative 4. Then I go to plug in 3. Again, always positive, so plug in 3 here, I also get a positive. So the point that I wanted to make with this video, and I'm not going to go any further with this video, but I wanted to make the point that if the sign doesn't change, 3 is neither. It's neither a max nor a min, right? So I could just say for a local max, DNE, I do believe that if I went on to find the second derivative, which I'm not going to, but I do believe that you would see that 3 would be an inflection point, okay? But I really wanted to make this point that when the signs don't change, right, then you don't have a max or a min, okay? It requires the function to either go from decreasing to increasing, which gives you a min, or the function needs to go from increasing to decreasing, which gives you a max. All right, so I think that's all we need to learn here. So thanks for watching.